I think we can start probably in 1 minute. How many people we have now? Let's see. We have 11 people now. I think that's including myself. That should be good enough. Okay, that's before we start. I see some people is new, so we want to spend a few minutes. Hope you don't mind, just to introduce our school. The main thing about our school and start from very beginning. So this is a series of seminars hosted by California Science and Technology University. We have invited the professors from Stanford and Berkeley talk about the foreign topics: 5G, AI, big data, digital economy, data science, and then blockchain. So today, I just want to cover some basics about blockchain. So next Monday, so you see the professor from UC Berkeley talking about blockchain. And in this way, you can understand better. I just try to give you some fundamentals, and then you have the idea. When they talk about the blockchain, they will talk from more academic world. For myself, I think it's a little bit challenging to listen to the professors from Berkeley's talk without this basic knowledge. That's what we try to do today. Okay, this is about our school. You have not heard about us. So basically, we have a training program. We have a master's degree program in MBA and the computer science. And then the good things about schools, if you're unemployed, then you don't have to pay the tuitions. The government can pay for it. Okay, that's basically about us. If you really join us, we have internship opportunities, and we also have a scholarship available. The scholarship will cover any gap between what the government can sponsor you, and then the rest will take over, cover for you, so you don't have to pay any tuitions if you're unemployed. If you're employed, talk with us. We also can provide you some scholarship, so you don't have to worry too much about the tuitions. Okay. Now I think we have 12 people. So let's get started with blockchain. First of all, I want to spend a very quick questions, and then if you know the answers, type in the chat, so I have some idea how much knowledge do you have. Okay, what is a blockchain? Anybody have any? I mean, you don't have to watch my or listen to what I have on the screen. In your mind, what do you think? What is a blockchain?
I have heard it's a distributed ledger.
If no answers, I want to pick someone, see what you think.
I've heard it's a distributed ledger.
No, still no answers. Okay, I see 6 here. 6, what do you think? What's a blockchain?
Can you hear me? Can you hear me?
We can hear you, Sig.
Okay. Distributed database. Okay.
Yeah, distributed ledger.
Who else? Okay, so I think that's pretty much a good answer. So that's what I want to say. Very simple answer. It's just database. Okay, blockchain is nothing very mysterious. It's just a database. What really make the blockchain different? Okay, this is the second part. It's a permanent. You cannot change anything in the database. Okay, you cannot change or alter the records. So that's something we at least when you go home today, you memorize one thing. I want to memorize. Okay, what really about the blockchain? Blockchain, in very simple word, is a database. The record cannot be altered, changed. We call it immutable. That's probably the most important part. A permanent database. So that's different from other database, right? We have an Oracle database. We have all the database. The thing is, you can change the database anytime you want to. You have the bank has a database, then they can change the database. So that's kind of things people want to solve. They say, okay, I want to have a database and the record is permanent. Nobody can change it. And then the centralized database is not an unchangeable record. If you really look at the bank records, they can change it. Okay, so that's the issues. People don't trust the centralized management database because you can change anytime. Okay, now the changes, how to make it possible. This whenever the computer is being invented, everything's digital. We all know the data can be changed easily. This is the digital. So the idea is how to make this immutable is basically what it says is a computational impossible to make changes. So that's what it means. It's true, you can change things, but then what the database is being designed, if you make a change, it will be detected and it will be discarded. So that's the idea. Now, how are you going to make this happen? Now, why we can detect the changes and discard the changes? I think the things we do not count on the centralized database. It has to be a distributed one. If everyone has a copy, and then you cannot make changes. Once you make changes, people will be able to detect that. Another thing is we do is called integrity checking. So if you make a change, then it's not just you have a different copy than others. The people can detect which block has been changed. We'll go to the detail, so don't worry about this moment. So now at this page, what I want to people memorized, just this is a permanent database, or is a permanent distributed ledger. So this database is just for records. Now, with this in mind, now people think about, oh, this is wonderful. So with these features, then that's what we can do. The things what we try to is make permanent database. Now, assuming you have that database, then you can have those features. Those being the advantages, resilience. Okay, now the database will still operate at in an event if there's a massive attack against the system. This is a distribute. Okay, to have resilience. Then there's a time reductions. Basically, what it says, whenever there's argument about the records, everyone has a copy, so you don't need to have any arbitrations, because everyone has a copy. So it's time reductions. Reliable, the reliabilities. Okay, so it certifies and it verifies the identity of the interest parties. No double records. Basically, it's unique, so reliable, very reliable, and unchangeable. We explain that. And as fraud preventions, because everything being shared, there's no possibilities you can make any fake informations, and oral transactions immutable. So just want to make this clear. Okay, immutable make a lot of things easier. Technical is harder, but then for operation wise, it's easier. And then transparency, everyone has a copy, so it's transparent. There's collaborations, means everyone has to work with each other. You don't need another mediating third parties. So it's P2P, basically we call the P2P corporations, and it's also decentralized. Okay, so that's kind of things. When we have this blockchain, we think, okay, we summarize, not we think, we summarize, okay, those are good features we can have. So now, here's some histories about blockchain. Blockchain was considered one of the 5 most promising technologies for the future. Okay, so that's considered the most useful ones. The most famous application right now still is the Bitcoin, the digital currencies. So this blockchain 1.0 is just a currency. Blockchain 2.0 is smart contracts. Blockchain 3.0 will be the DApp. DApp is decentralized applications. So for today, we don't really go to all of the details. We just talk about how the blockchain works. So it's fundamentals. So we don't really go to 1.0, 2.0, 3.0. So just so that you know, we have 1.0, 2.0, 3.0 now. So what are we going to solve some the myths and the realities? Okay, so that's what about the blockchain. Hopefully that's make it clear to everyone's mind. So the first thing is it solves every problem. No, it's just a database. Very simple, it's a database. Okay, so I start from very beginning and say, okay, it's just nothing but a database. And it's a trustless technology. Well, that's not true. You can shift trust and also spread trust. Yeah, so we can see that how this is being done later. And it's secure. Okay, that's pretty secure. But the security, as we mentioned last week, right? Security has a bunch of things, a few features. So last time we talked about communication securities, including 3 things: integrity, authentications, and then the confidentialities. Here, when we say the secure, it only means integrities. Integrity means every single record cannot be tamped by any hackers. So we have integrities, but not necessarily confidentialities, because it's transparent to everyone. Everyone can see it. It's not being encrypted. So there's no confidentialities. Then you can do smart contract, always legal, but that's something we have to make it clear. This is only excuse, means legal is not making it legal. You just make it a contract. If the contract itself is legal, then it's legal. If the contract itself is not legal, then the blockchain will not make it legal. Okay, so this is just execution part, not the contract itself. Now, what about the immutable? This is about the computer science. Okay, when we say the immutable means at the current technology, there's no way, impossible to make any changes. What about future technology, especially the computing power? Well, that's possible to make changes, because you assuming you have 1,000 times faster computers, then this technology has to be updated. As I mentioned earlier, last week, we said, okay, all the securities is based on current computing power. You say now I increase the computing power by 1,000 times, even 10,000 times, then the technology may not necessarily still true. Okay. And then another thing is about electricity, right? So a lot of people think, oh, this is waste electricity. Actually, the blockchain has been improved. Now it's quite efficient. Doesn't really waste electricity. Bitcoin is a different story. I will cover that later. And then it says, okay, it's probably useless. But then the reality is the blockchain is just a platform. With this immutable records, you can have many applications. As I said, the most famous application right now is Bitcoin, but then it can be applied to other applications too. So that's very basics about blockchain. Before we go to the details, I hope that kind of concept, then you have this being established. You have this blockchain, the big pictures. Now let's go to a little bit details, the architecture. So what really the database is about, right? So it's architecture. First, what's a block? Right, we use this Bitcoin as Bitcoin is based on the blockchain. So what's this block? Okay, so in this case, the block is just say that's a transaction from this guy send to Peter and send the $200 Bitcoin dollars to this guy. This is a record. So you put everything in the record. We call that a block. So you can see there's a block 1, block 2, block 3, all the way to block n. And then the database, you can keep adding the blocks whenever you have additional transactions to add one more block. and then you chain them together. When they chain them together in computer science, basically just you have a pointer. You can go from here to here. So then you can see this is basically a series of records. So that's database, as I said, database. So this database, with this architecture, you just keep recording all the transactions. Okay, we call it records. So that's basically the blockchain block. So it has a block and chaining together. So we call them blockchain. What's really special about this blockchain is this chain, right? So those chains you will see later. How do they chain them together? Not just like pointers. Actually, they have something built in. So the first block is the initial block. It doesn't really have chain to a previous block. So they call it the Genesis block. So what do I mean? The chain is like this. Okay, do I have another one? Here, I will go back to the previous one. Okay, so you have the block 2 has to include something we call the hash in block 2. So the block 2 has to include everything in block 1. Then block 3 has to include everything in block 2. What they include is called hash value. And what's the hash value? I can explain to you. So basically, the later block will have the information of previous blocks. So then you cannot just change one block. All the blocks after you has to be changed if you change any block. So that's make the change very, very difficult, impossible. Okay, that's the ideas about the chain. Okay, so this chain has some meaningful definition here because the block 2 has to include some information about block 1. So what should be include block 1? We call it hash. Okay, now we explain what's hash. So basically now we make a further the definitions of our blockchain. So it's a simply we can simply define it's distributed, it's secure, it's a log file, right? This is a blockchain, and not just database now. It's a distributed, secure log file. Now we try to use a simple definition is a shared ledger for recording the history of transactions that cannot be altered. Now you can see the blockchain is really a history of transactions. Here's some technical part. The first part, how does blockchain authenticate a user? Okay, you've been here last week, you know what authentication means. Authentication basically means you have to verify that user is a genuine user, whoever who claim to be. Okay, so that's been done by private public keys. Okay, I'm not going to explain this private public key today because we explained that last week. So we only, okay, let me try to quickly review a little bit. Okay, so that's the user. If you join, blockchain is a platform. Basically, when you join the platform, you have to create the self-solving identity. So that's a data platform. You create your identity and register a decentralized identifier called DID. And then you have to create a pair of private and public keys. The private public key is used for encryption and decryptions. If you don't know the concept, you can probably review that later on after the lecture. The private key is only for yourself. So the assumption here is everyone holding a private key, you only yourself know the private key. And then for the public key is known to everyone. It's public. Everyone knows the public keys. The authentication process basically, if there's a person called A or user A, user A said, okay, I'm the user A. How to prove you are user A? All you have to prove is I have user A's private key. So this assumption is clear. Okay, whoever has the key is the person. It's like you have a driver license, right? You have a driver license. Then with this driver license, you can prove you are the person. The driver license is yours. Same thing, but this is a digital world. It's not like a picture license. It's just your private key. So the private key is your identity. Now, if you don't know the public private key, encryption, decryption, just remember one thing. The private key is your identity. You cannot share this private key to anyone. Anyone holding up, anyone can get hold of your private key. Basically, they can, we consider this, your private key is not yours anymore because they can pretend to be you. So this has to be only yourself knows that key. If the private key being hacked, you need to get a new pair of private and public key. Okay, that's the first thing. So the user can authenticate himself by encrypting a personal information with the private key of the user. So that's how we do the authentications. So what do I mean? The person can do by encrypting the personal information to prove the user. So basically, let me try to use this pen to write something here. So make the a little bit clearer. If this is not so clear. Okay, now let me see if I can draw. If you have a pen. Okay, let's do this. Okay, assuming this is the person A, right? This is A. A has a private key. We give private key is private PRI. Use this private key. They can encrypt. Okay, do the encryptions with any information they have info A. Okay, if you can do this, that means you are person A because you know the private key of A. Now, how do I prove your private key of A? So that's the decryption process. Decrypt this piece of information with what? With public key of A. Okay, public is everyone knows the public key. So in this case, the inside is encryption, outside is decryption. Encryption, decryption, then you got information A back. With this process, okay, if the guy can show you this encrypted message, because that's basically proves one thing, he has the private key, because only A can do that. Nobody else can do that. And if A1 decrypt this piece of information, got information A here, that's just a proof. Okay, this guy is A. Okay, so that's important assumptions. This private key of A does not belong to anyone else except A. So that's the first thing to authenticate a user. That make anybody who join the blockchain platform will be authenticated. There's no way you can fake a person. I hope this concept is clear. Authentications. Second things, I want to explain about the hashing technology. A lot of people may have heard about hashing. Some people may not. Okay, so bear with me if you know hashing already. So what really hashing means? Hashing basically is a one-way function. Okay, when we say encryption, they have a reverse function. Okay, decryption. Hashing does not have a reverse function. So what means if you have keys, this is your keys. Okay, then you through a hashing function, you hash to different slot. This is called hashing function. But then, for example, 02. Okay, the Sandra and John, they both hash to 02. So you cannot reverse them back because you don't know it's from John or from Sandra. So the hashing function is not reversible. Whenever you say a function is reversible, the minimum requirement is 1-to-1. You have to have a 1-to-1 mapping, then you can reverse. This is a multiple to 1. This is not a 1-to-1. This can be m multiple to 1. So it's not reversible. In general, you just hash a long string or larger number in small numbers. So that's called hashing functions. Let me give you very simple examples. The reality, or in production, we don't use these examples. So here I have 10 numbers ranging from 0 to 100, right? Then I hash them into 5 slots. So whenever I have a number, I do a modular operations, module 5. And then you will see they will be placed in the different slot in positions 0, 1, 2, 3, 4. So this is the hashing. Hashing means you convert a long string to a short string, basically. So why this is useful? Okay, that's how it be used. Hashing is being used for integrity checking. Assuming this is the block information's very long string. Now you hash them into a small number, right? So basically, what we're trying to do when you have a big block, you are comparing, for example, the blocks is a 64K, then you will see the comparison of 64K digits. It takes a much longer time. So with hashing, we only hash them to, for example, 128-bit or 256-bit. Then we can do a very quick comparison. So another terminology for hashing we call the fingerprints. So we say, okay, I have a whole block. So I do a hashing. And then once I hashing, the block you have data and then the hash, the previous hash. So you don't really save everything or compare everything in the, when you do the comparison, you don't really compare the entire block. You only needed to compare the fingerprint. So that makes the things much more efficient, especially when we have a long blocks. Each block have the hashing of the previous block. If you don't have the hashing, you have to compare every single blocks. And that takes forever. So now with the hashing, all we have to do, as I mentioned earlier, you only keep a hash value in the next block. So the 7B2Z is this hash value of previous block. So you only keep this 7B2Z in block 3. Block 2 keep the hash of block 1. So that's the in other words, we only keep your fingerprint for comparison. So now the question is, what's the chance the hash collide? When they collide means you have different blocks but have the same hash value. Well, that's possible, but then that's just the chances are very minimum. You can pretty much ignore that case. Just the assumption is whenever you make any changes here in this block, your hash value will change. But then maybe like in very little the chance you make a change, then the hash value does not change. That's what we call the collisions because they have the same hash value. But that probably you can just ignore. The reason you can ignore because the hash algorithm is so well designed. You touch any bit, and then the hash value will change. And it's very hard. It's more likely it's impossible to find the two block contents which has the same hash value. In theory, it's possible, but in the reality, it's unlikely. That's why I said whenever you use this integrity in the computers, it's not always 100%. It's always pseudo. Pseudo means computationally it's unlikely. So that's the blockchain hash. So you use this hash as a fingerprint, so then you can include that fingerprint in each block, the previous block. So in this way, they will chain together. Anything change in the previous block, the hash value will change. And then the next block, the hash value will be changed. You change one thing here, one bit here. If you have 100 blocks, they all will be invalid. Because that the hash value, the only one bit being changed. So that makes impossible for any people to try to tempt the the data value here. Another thing is you may not be able to do that is you have distributed database. When it's in the distributed database, then there's no way you can change everyone's blocks. Okay, that's a one. There's a one question: how main information is visible and that's not confidentiality? Nothing is being encrypted. Okay, so it's clear, it's transparent. We are focusing on the integrity, not the confidentiality. So it's like a database. Everyone can see the database. You just cannot change it. Okay, I hope this is clear. Any other questions?
So when you say you're you're mining, you're Bitcoin mining.
This is called the integrity. Okay, you calculate the hash value of the block. You compare the hash value of the block with the calculated hash value. So whenever you check the integrities, each block they have a hash value. So what you want to do check, you just compute the hash value and compare with the hash value in the block. If they matched, then the integrity is okay. If not matched, then something has been changed. So that's called integrity check. Now, who's doing the checking? This is a distributed systems. Okay, everyone contribute. In other words, everyone doing the computations. Okay, now, second part about authentications, right? So we try to say earlier about public key and private key. Okay, here is actually I add one slide here to say what we do. Here is called digital signature. This is a authentication, not authentication. This is trying to authenticate who really create a block. It's not authenticate the user itself. It's authenticate the block actually indeed being created by the sender. How do you verify you create this block? You know, whenever you create a block, the user has to claim, okay, I created this block, and the other people have to believe that. This is being done by digital signature. Digital signature. Okay, digital signature works this way. Assuming, okay, it's always Alice and Bob, okay, AB, for the security part. Okay, now this is the message, hello Bob. So Alice, okay, hello Bob. But now how you can prove this Alice says so? So Alice had to sign with a digital signature. The signature means they use their private key to encrypt this message. This is called digital signature. Hello, Bob is a clear message, but then I sign that, say, hello, Bob, I sign that, then become an encrypted message. When Bob receives this message, then he has to use Alice's public key, because the public key is known to everyone. I mean, Bob definitely knows that. So he uses Alice's public key and decrypt this message. And then you got the message back, say, oh, it's hello, Bob. Okay, now, because this has been decrypted with Alice's private key, Bob will know this message is sent by Alice. So that's one of another authentication part. And we know each sender, they will digital sign the block whenever they try to create a transactions. So that signature also verify, or we say authenticate, who sent that transactions. In other words, you cannot dispute that because you sign with your digital signature. Okay, there's another question here. Then the blockchain is loaded off of full public keys. Okay, public key is known to everyone, and you can put it in the blockchain or you put it anywhere. Okay, so the assumptions public key is known to everyone. You can ask for it. So this is public information. Now, how to implement that? That's up to the implementations. Okay, nowadays with the computer communication technologies, you can assume you can put it anywhere you want to, as long as you can get it. So in website or in a node or in whatever, you can ask for it. So this is not an issue. This is an easy issue to solve. Okay. The only thing you keep in mind, the private key is only being kept to yourself. Okay, so now you can see there's two things going on. One is the integrity of a block is checked by or safeguarded by your fingerprints. When I say fingerprints, hash value. And then the block, the author of the block is being guaranteed by digital signatures. So this with this tool, then that's impossible to make any faked block. So that's called authentication in the blockchain. Proof of work. Another thing, blockchain has a strategy to prevent the people who to prevent people to tamper with the blocks. Okay, so this is one of the blockchain's technology, is especially being used in Bitcoin. So what is that? Okay, this is not a Bitcoin lecturing. In the next time when we explain the lecture, I tell the details. So for time being, in case of Bitcoin, whenever you want to create a new block, they will ask you to do some calculations. Okay, they call it proof of work, to add a new block to the change. Now, how long it takes with current technology is about 10 minutes. So that's intentionally being added for the Bitcoin. But blockchain actually allows you to do that. So just make it tougher for the hackers, because consider you have 1,000 blocks. If you want to make any new blocks, each one takes 10 minutes. So it takes a lot of time to build a new block. That's actually the Bitcoin mining, why the Bitcoin mining takes so much power, because intentionally they want to do a lot of computations. It takes about 10 minutes to create a block. To do that, you need a lot of computation power. So that's not the blockchain itself. It's just a way of security.
So Glenn, is the mining?
But we don't really focus on the proof of work today, because that's specifically for Bitcoin. So next time we go to the Bitcoin, we cover this part.
Hey Glenn, can you hear me?
Now, distributed P2P network. The blockchain uses a distributed P2P network, and everyone is allowed to join. So that's no central server to managing the entire network. So when someone enters this network, he gets the full copy of the blockchain. If you apply for it, as I said, okay, you could become the node or become part of the network. Then you get the entire copy of the blockchain. It doesn't really take much longer time, because the communication is pretty fast. You maybe less than a minute, you get an entire blockchain. To tamper with the blockchain, you needed to tamper with all blocks on the chain. So that's what we said, okay, is immutable. It's not just the block itself. You have so many copies in the entire platform, and everyone has one. And then to change one single block is unlikely. Okay, especially you will have a proof of work for each block. Then that takes even longer time. When I say it's a longer time, whenever in computer science, we say immutable is always probability. In probability is unlikely. I mean, it takes 1,000 years, so we say that's immutable. But you say in theory, if you give me unlimited time, it's possible. But in reality is impossible. So that's why we said from the very beginning, blockchain is a record which is immutable. And with this feature in place, then you can do a lot of work, and then you can trust. So you build up the trust of the blockchain. If you have a centralized database, you do not have the trust unless you just 100% trust the bank or whatever the central server. They will not make any changes. Okay, let me see. There's some questions here. Some audience ask questions, but it seems you don't hear them. Oh, I see. Maybe I have my speak off. Okay, let me see. I turn on my speakers. Okay, let me see. Sig is asking questions. So mining referred to the computation performance for both hashing functions and proof of work. Okay, that's a different story. I think Sig is asking this question about the mining. Mining is for the Bitcoin mining. Bitcoin mining is slightly different. It's just the way the Bitcoin is rewarding the people who can do the verification of the blocks. Now, why the people do all those things? So one of the things for the blockchain to verify each block is every single node do the work. In Bitcoin, they give you some reward. So basically, you verify the blocks, they give you some coins. So that's why the data mining means you try to have a very powerful computer. You do all of those computation work for the network, and once you have done that, then you get a reward. This is Bitcoin mining. Okay, we will cover that later. So for now, we try to explain the minimum fundamentals. We have a blockchain, which is immutable database, also distribute. Now, you want to really take control of greater than 50% of the peer-to-peer network, then you can make changes. So there's some policy about the blocks, right? There are some cases, even you have the block being updated or being included. Now, there's a case because this is a distributed way. So for the same information, if there's two people to try to build the same block, then who is the winner if you're doing the same thing? And who actually has more block being verified is the winner. Okay, once the winner wins, the other party has to discard their blocks. That's give you, in theory, if you try to doing things so fast, you take control, because that's always possible. You have inconsistent blocks in the network. So that's, you are thinking, oh, maybe I can doing things so fast. I want to change something, and then other people see I have done these changes, and then they take control of the entire block, entire blockchain platform. So the rule is you really have to control more than 50% of the P2P network. Then you can discard the other copy of the blocks. With this all the time-consuming things here, that's unlikely you can change the existing blocks. That may only happen from the very beginning. If the two people simultaneously try to update or create a new block, then who is the winner? If they have more people support, then you'll be the winner. So why they have created something? Why they can create same block with a different hash values? That's Bitcoin. So there's a proof of work. So whoever finished a proof of work first, then we get a reward. So then there's a competition going on. You can mine the coin, but not necessarily you get, receive the coin. You really have to be accept, then you can get a reward the Bitcoin. So that's, don't worry about that for the time being, because this is not for today's lecturing. Let me see. There's another question here. Okay, so when we have here about Bitcoin being hacked, the hackers have not tampered with the blockchain. They hacked people's identity key. Oh, that's a different story. Okay, if you lose your identity keys, you lose your Bitcoins. So that's as simple as that. And your ID you lose, and then there's nothing we can do about it. So that's the nature of this blockchain. You have to hold on your private keys. If you have, I have the digital wallet. Right? When I switch from my old phone to the new phone, and then why the wallet money going to transfer over because I have the key. Now same thing for same theory. If I have your private key, I can transfer your money over to me. So your private key is your IDs. Once your IDs get lost, then there's no security anymore. Okay, how does a blockchain works? So first, you request a transactions, right? You request the transactions here, transaction request. Then you broadcast the request. The network of nodes validates the transaction, and the user. Okay, the user, we mentioned about how to validate the user, the authentication of a user, use the private and public keys. Once the transaction is complete, the new block is added to the existing blockchain. So when I say the transaction is complete, the verification, the hashing, all being verified. At that point, this new block will be added to the existing chain. So that's added to the blockchain. You validate. And then when you say the validations, basically you validate the hash values and add also the user's authentications. Everything's being complete by every single node, and then you add to it. Okay, at this point, there's some risk conditions. That's what I mentioned earlier. In this case, whoever has the more support is the winner. Once you've been added to the chain, then there's no way you can change it. Why the transaction energy efficient? I think the newer algorithms, they the last of when the chain get longer and longer, then you need more and more computations. So the newer algorithms will become more efficient. That's a very advanced level because we even have not talking about the blockchain platform, how to create those transactions. So you can see the blockchain, the blocks keep adding to it, right? So that can become the concern is we have more and more blocks, then the validations become a burden. So there are some improved algorithms to avoid this problem. So that's what I said, that the newer version actually become more efficient. I think the main complaint from people is, you can imagine, okay, now from the very beginning, you only have a few blocks, that's fine. Now, as the time goes by, then more and more blocks, then you need to fix that problem. Okay, so the question here is, the network of nodes, how are nodes chosen for validations? Okay, if you want to join the network, that's the time you need to create your identities. That's why I said the DIDs. The nodes chosen for the validations, every node participates for the validations. It's not how you choose, right? Which one being chosen is distributed network. It's always by contributions. In the blockchain, the theories, everyone do the validations. But now in the actual application, this is the platform. You have to give people motivations to engage the validations. In the Bitcoin case, people compete for the validations because that's many awarding, especially when each Bitcoin is like $60,000. People really try the best to get more rewarding. Okay, so that's the democratic way of managing distributed systems. Everyone participate. Now, this is in theory, but in actual applications, you still have to give you motivations for people to do that. Okay, I hope this is clear. Okay, so here, actually answer these questions. Another question here. Okay, no more questions. Okay, now, how does a block get verified? Right, every participant helped validate the block. Okay, this is a computer, and then you join the network. It's not like you intend to do or not intend to do. Once you join, you hook up to the network, and then your computer have the process running in the computer. The process will do the validations. Okay, so that is not your control; it's network's control. And you use the cryptography, that's basically the encryption decryptions and digital signature to prove identity, the authenticity, and enforce the read, write, asset right. Basically, this is just authenticate user, use the digital signatures. So everything to ensure to authenticate the user or authenticate the block. The user has to be authenticated, the block has to authenticate. And then the validations is basically to check, to calculate hash values and compare them and make sure they are correct. So that's integrity checking. So two things being checked. Okay, if you look at the blockchain, two things being checked. One is the user's identity. Second is block's integrity. So that's blockchain about. So you don't really go to the technical coding details. That's all you need to know today. So we're going to review what I've done so far. Okay, hopefully that gives you summation. Summarize what we have discussed so far. Blockchain is just a distributed ledger technology with immutable records. That's what I said from the very beginning. A new data comes in, they are entered into the fresh block. Once the block is filled with data, it is changed into the previous block, which makes the data chain together in a chronicle order, so that you can see each block is related with your previous block, because you have to include their hash values. And then once the hash has been included, then you calculate your own hash values. So your own hash values has previous blocks have hash values. Same for the previous block, unless you are the first one. So different types of information can be stored in a blockchain. It's not necessarily has to be Bitcoin, but Bitcoin is one of the successful applications. And most common use for has been a ledger for transactions. So now let's see, maybe I have some examples about applications. So decentralized, the blockchains are immutable. Very important. Talk about from time to time and repeat it many times, which means the data entered is irreversible. Just cannot be changed. With this feature, you can imagine a lot of applications. Money is definitely is a good one, because you cannot arbitrarily change your money amount. Now you go to a bank, go to Chase Bank, you put money in, they give you a statement. Now, what if the bank changed that record? Because technically is unlikely, but technically it's possible. In practical, it's unlikely, but then this is possible, because they can do the changes. They have a centralized control. If the person has the authority, they will be able to do it. It's just a software, and other people may not be able to do it because you don't have the authorities. But with the people who have authority, they can change anything. But then, blockchain in theory, it's just nobody has the power. If that's the case, you can fully trust the blockchain. For any applications, transactions, you can book anything. Then you can imagine, as long as they are in part of the blockchain, then you can 100% trust this is a genuine. There's no fake information there. So each block will include the hash value of previous blocks. All members has a copy of the blockchain. Thus, it's impossible to any changes without being detected. So that's a very, very strong statement. Okay, versus like a bank. I've seen those news. Okay, I deposit my money in the bank after a few years, the money is gone. Then they have already traced back. Okay, see what happens. But that means they still can do it. In the blockchain, this is some summaries. The most important part: decentralized, transparency, and immutable. That's all you can take home today. Okay, questions? The blockchain is transparent. It is therefore traceable to drug dealers. No. Okay, so you can register yourself, right? So we don't know who you are. I just know this is A, but who is A? I don't know. It's not like you have a passport issued by, for example, US government. I look at the passport, I know who you are. But now you just know you are a node, and you register with node. I know you send this informations, but who you are, who are you? I have no idea. Okay, so that's different story. So the authentications only means we authenticate. This is A, but I never said okay. It's like the legal. I mean the smart contract. I can execute the execution part is okay. You can establish the contract between A and B. And nobody can argue about the contract. Is this contract legal or not? This is not blockchain's idea, responsibility. Okay, now I think the rest will be the blockchain. I mean the Bitcoin. So, I don't think I have time for Bitcoin, so I'm going to stop right here. And next week we're going to have the professor from Berkeley to talk about blockchain and applications more in the academic world, how this is being implemented. So maybe you can listen to to what the research is about. And for me, I only give you the basic knowledge. Hopefully, after today, it will be very clear to you what they're talking about, what the blockchain is about, what it can do, why we need a blockchain. But then for the actual applications and some theories and the latest greatest research, then you can come back next week. Okay, that's all for my talk planned for today. The rest is about Bitcoins. I think we'll not get into Bitcoin today. There's another big story. Now I have a few minutes and open for the questions. Okay, Mahmoud, what is blockchain engineering job? How do you learn? Okay, blockchain basically, this is an open source project. I think in the previous, I see a lot of people try to use blockchain for different applications. Like Bitcoin definitely is one. You create digital currency. There's a lot of job. You can create a Bitcoin. You can create Ethereum. You can create dark. I mean, what's the dark currency? There are many currencies. I have one currencies in my digital wallet. I have like 10,000 currencies worth about less than $1. You can create any application you want to. At least you can create. For example, you can create your own currencies. Now, how much it is worth, I don't know. It depends on the market. If the market thinks this is something very useful, you can prove yourself, improve the algorithm, more efficient. People like to use more convenient, more acceptable. Then the value goes up a lot. When I remember the Bitcoin first released, $1 can buy a few coins. Just nobody think this is anything useful. It's just a series of numbers. There's nothing else. Right now, nobody can imagine it goes like $60,000 for one coin. So that's basically what it is. For the supply chain, you use supply chain to make sure everybody in the chain is being authenticated, and you prove their identities. Then you can use a blockchain network. Then you can authenticate every single supplier. So that's kind of a typical application. I have seen one person. I went to the job fair for blockchain. Basically, I asked, hey, what are you going to do with this blockchain? He said, we are in the hotel management. When I book the hotels, there's a chances, somebody booked the hotels and they say, I didn't book it, right? So that's kind of interesting things happens. So if you have this blockchain, then you cannot deny it. So that's a lot of things you can, whenever you think, I want to have immutable records for transaction to reduce those arguments or whatever the issues we are with their business, then blockchain will be a good platform. Now, in terms of the jobs, all the work down here, including the interface, this is an engineering job. So that's one time, I think back to before the pandemic, at least before the pandemic, I went to a few job fairs, especially focused on blockchains. So those are things I have seen. Nowadays, I think it's still pretty hard, but very specific. Pay to earn gaming platform on Ethereum network. How do you build a blockchain application? Okay, this is an open source platform. You can download this blockchain platform, and then you define and design the application you want. For example, the gaming. Now, the gaming, you can define a system of the award or pay for, like the tokens. Then you ask people to pay for it, and then they can play for the game. So you can create another set of currencies. So this is one of the applications you can do. It's open source. If people really want to dive into it, you can download. Even like in a few years ago, I'll keep mentioning the wallet that I have is one of my friend. They design digital currencies. Okay, then I said, okay, give me some. They just give me 10,000 or something, and then I check the value is less than $1. Okay, anyway, so that's the story. Is it on the GitHub? Joe, you have to search for it. Okay, I think the GitHub may have it, but I myself, I didn't really do any the blockchain platform, the development, so I cannot give you the advice. Private and public blockchain can coexist for same users and data. Now, the private is their own. Okay, public blockchain everyone can join. Private is just their own, so they are separate. Okay, if they have the same blocks, this is a database. Basically, data. I mean, if they want to keep them private, they don't want to share with public, so they cannot share each other. If they share each other, everything is become the public. Can still someone fake their identity and still be able to open an account on blockchain network? How do you verify someone's identity? As I said, okay, the blockchain itself, they don't care your actual identities. So this is not fake. You create ID, then it's you. So that's no fake or true. They don't really verify is this your true ID. That depends on how you define your identity. You can call yourself Joe. The next day you call yourself John. That's all you. Then we register with the blockchain and say I'm Joe. Then you are Joe. Next time you say I'm John. So now you're not Joe anymore. But then you have a different IDs. So you can create different IDs. Is self-sovereign identity always and only associated with authentication for using blockchain? No. You can use for other things. Or is SSI just related to authentication using public and private key? Yeah, SSI, the sovereign identity is related to authentication using public-private. Yes, that's true. The public and private key is just one algorithm. It's a very generic algorithm. It's being invented by RSA. But there's a lot of improved version. So the original version is called the RSA. But now you can see some people has, based on that algorithm, they invent some same idea, but more efficient algorithms. But then we don't really have to cover their algorithms. Just for us, all we have to know, you have two keys, one public, one private. How are you going to use this key for decrypt, encrypt? There are many algorithms. But if you look at the textbook, they always ask A. Does NFT require a different platform or can share with Bitcoin and other existing platforms? Okay, that's for the future seminars, NFTs. So NFT, this is also for the authentications. Okay, so we're going to use the different platform or can share with Bitcoin and other existing platform. This is just a Bitcoin platform. But then in general, I think the NFT, they have their own, design. When you say the share, everyone's different. It's like Facebook, they create their own. They don't want to share with anyone else. So this is not technology issue. This is a business issue. Okay, any additional questions? If not, that's for today. Okay, now do blockchains have their own coding language? They have the interface. If you think that's a coding language, for the platform itself, it's open source. You can dig into it. So to use the blockchain, you're not necessarily has to be studying with whatever the language they're using, but they can provide you the interface. Then with this interface, you can use whatever the language you want to use. So that's software issues, right? So platform itself, they always have some interface for you. Okay, if you're a software engineer, so you can see like the many platforms, they sometimes they can mix different languages. I think you're talking about the Java or C++ or Python or the high-level languages. So now the language itself, there's no issues to integrate with each other. Okay, is blockchain runs in the cloud? It's definitely you can run, everything can run in cloud. Is there a need for local PCs? No, everything can run in cloud. If you run on local PC, also fine. So it's not an issue. Okay, so we have the cloud computing seminars coming. So then you will see when the cloud computing come in, there's no difference between cloud and the local PCs. Well, PC, think about it this way. Everything is connected. And then PC also connect to network. So cloud and PC, there's no difference. Right, so everything is just connect to the internet. And then whenever there's a node, you don't know where they are. When you see the local PC, because it's only local to you. But for other people, they are not local. Private key is local. What do you mean local? Private key is personal key. Okay, it's always to yourself. So if you say it's local, I don't think it's accurate enough. It's just your own. It's in a personal PC or the phone, it doesn't matter where it is. You just have to have a safe place. It can be in the cloud, but you have to hide it. You don't give the access to anyone else. Where you hide it is up to you. But for my PC, for my phone, I have an ID, which is only I have the access. Other people may not have. Other people do not have the access, right? So local is too general. Right? When you say local, I think you mean something you can access. You can access anywhere you can access, as long as it's only you can access. So it's not necessarily has to be local. Just have to be safe. That's all.